Hello everyone, this is Swagonfly and this is episode number 11 of our Halo 5 Force tutorial. This is going to be a very lengthy episode because this method is purely experimental. So this time we're going to go ahead and take a deeper dive into AI. So far we've created AI that can navigate through objects, that can attack you by telekinetically throwing other objects at you, and doing a number of pretty cool, interesting things. And that's great, that's very good. Now, the issue with the previous AI that I programmed in our previous tutorials is that they are essentially wind-up dolls. Like Halo 5 Forge scripting, they wait for something to happen until they go ahead and take an action based on what you told them. So they just wait for something to happen and they do what you're told. But what if we created an AI that could uh, take a decision before something happens? And what if we could create an AI that can essentially think its way through a problem, a pretty simple problem? And what if we could create an AI that can anticipate something and take action based on that forecast that he's created in his mind? Well, in Halo 5 Force, this is actually possible. It's entirely possible. And it's not too different from a traditional machine learning model in which it gathers data to make a prediction and take a decision based on that prediction. And I'm going to go ahead and show you a very basic and very simple version of a machine learning model. There's many different ways to do this outside of Halo 5 Forge scripting in the programming world. However, if you understand these concepts, this can actually help you outside of Halo 5 Forge tutorial if you decide to go into programming and start specializing in AI in the future. So we're gonna go ahead and uh, show you the ropes to see how we can create a very basic machine learning model in a Halo 5 Forge map, and that way we can go ahead and make some pretty interesting maps and breathe life into a machine that can essentially take decisions and think its way through a problem. So how are we going to do this? How do we create a machine, an AI that can actually think about a given situation and make a decision based on that instead of waiting for some very specific thing to happen? And I'm gonna go ahead and show you in a moment. All right, so basically what we want to go ahead and do is we want to be able to track player performance. We want to create a tracker that gathers data, and that data is recorded in the AI's sophisticated uh, tracking system. And this is actually going to be the building blocks for machine learning. So let's go ahead and uh, add some pretty interesting items here. Let's start with some vehicles. Let's start, for example, with a mongoose. And then we're going to add a warthog as well. And then we're going to add a scorpion. Cool. Okay. So aside from that, we're gonna go ahead and add some weapons. For example, let's go ahead and add a DMR, right? And we're gonna go ahead and place that over here. And then we're gonna go ahead and add a tier 3 weapon, a rocket launcher, right over here. And then last but not least, we're going to create a script brain. And we'll get to that in a second. But we're gonna go ahead and bring all the tools we need for data tracking. You can add more objects depending on the situation and depending on the scenario you want for your map. However, these are just a few examples of how you can use these objects in general to track a given team's data. And now this is where things are going to be a little bit more complicated. So you do want to go ahead and pay close attention to what we're going to do next. All right, so the next thing we're going to go ahead and do is that we're going to essentially establish a boundary for each object. And these boundaries are going to be used to track player data because it's going to tell the AI that you're interacting with this object. And what we're going to go ahead and do is create an AI that can forecast the chances of victory for a given team based on what they're doing right now and where they are located in the map. All right, so let's go ahead and create a bunch of boundaries for these objects. For the mongoose, let's go ahead and do a 16-8-8 boundary. Okay, that might be a little bit large. Let's go ahead and do a 12-1. There we go. For the warthog, we can go ahead and do a pretty much the same boundary, 12-8-8. Should be enough to detect a player's presence inside the boundary. 12-8-8. 12-10-8. 12-12-8, just in case. And then we're gonna go ahead and take the scorpion's boundary and we're gonna make it a 24-14-14 boundary. And for the battle rifle, we don't want to make this boundary too big because we don't want it to detect multiple players in a given boundary unless you're in a vehicle. And we're gonna go ahead and make this a 8-4-4 boundary. And that should be good enough to detect the player inside it. And we're gonna go ahead and do the same for the rocket launcher as well. So 8-4-4. Alright, cool. And now we have our script brain. This is going to track a player's location in a given area. And we'll get to that in a second. But let's go ahead and finish up on our boundaries. So let's go ahead and do a 32, actually no, 1,250 and 1,250 boundary. And this boundary is a little bit too fast. Let's go ahead and make it a 24. All right, cool. So we have our boundaries assigned to our, our vehicles and everything. And basically, what we're gonna go ahead and do with them is that we're going to use their boundaries as a tracker. So let's go ahead and allow it to show their boundaries. Now, this is where things get pretty interesting because I'd rather play it safe and do this for team-based maps instead of FFA because, tracking data in FFA can be very tricky. But in a team-based map, it's much easier to create a forecast with player data. So let's go ahead and leave these boundaries visible. And now what we're going to go ahead and do is that we're going to essentially assign a team to these objects. These objects need to be assigned to a team. So we're going to go ahead and put red team as the defenders, and then we're going to duplicate these objects. And basically, we're going to assign these to blue team. Let me go ahead and turn this around real quick. And this will be blue team's weapons and vehicles and all that. So, great. All right, fantastic. Okay. Cool. And let's just, deal with that. And ungroup these items. Okay, cool. Now, we have red team's vehicles and items and all that, and then we have blue team's items. What happens next? Okay, so you're gonna have to create a lot of scripts. Now, keep in mind that in a map in Halo 5 the script limit is 512. However, you do need to be careful about how these scripts are executed, because if you execute multiple scripts at the same time, it could cause the scripting system to act up and not work properly, and also cause a lot of bugs and glitches. So you want to keep that in mind for efficiency purposes. You don't want to crash the map based on improper scripting. However, in my experience, this should work just fine without any issues. But let's go ahead and take a closer look. Okay, so we have our objects of each given team that track player data with their boundaries. Now we're gonna go ahead and create the AI itself. So this AI is actually gonna come in the form of two objects. One for evaluating a situation based on data gathered, and the other one is for making a decision based on the player data, based on the forecast created by this object right here. So let's go ahead and try to distinguish them a bit. And I'm gonna go ahead and give it a green color, just to give it a pretty neutral color, and that would be the evaluator. And this would be a yellow colored script brain. This would be the executor. So this one takes the decision based on what this thing has forecasted to do. Okay, cool. So what's next? Just for debugging purposes, I also want to go ahead and add a terminal to this, just so it can go ahead and reset everything. And we'll get to that in a moment. All right, so what's next? Okay, so basically what we want to go ahead and do is create a global variable. We want to assign, we want to go ahead and assign a global variable, two global variables, actually, one for each team, which is going to be used for record keeping purposes. So in this case, let's go ahead and go back to these objects real quick. So we're gonna go ahead and select all of them since they're going to be essentially doing the same thing. And we're going to press P for property, scroll all the way down and add a script. In this case, I previously mentioned in the previous tutorial that the boundary continuous is buggy. I actually found a workaround that to allow the boundary continuous event to actually detect players in a given boundary and take a series of actions based on that. So just for future reference, some actions don't work properly if you use the continuous boundary check event. For the rest of them, it should be fine. But for continuous, you need to take a few extra steps. So basically, what you want to go ahead and do is that instead of taking the action you want to take in the continuous boundary event, you actually want to go ahead and send a message, and that actually circumvents the bugginess of boundary check continuous. So it's all about sending a message in whichever channel you'd like. In this case, I'm going to put channel alpha, and basically what we're going to go ahead and do is we're going to go ahead and take the evaluator and make it respond to channel alpha. So once it receives the alpha channel message, basically what we're going to go ahead and do is we're going to add to the data point. So basically what we're going to go ahead and do is use global alpha, and what we're going to do is assign what I like to call a data point, quote unquote. It doesn't actually add points to the map, it just adds points to the forecast to help guide the AI, help the AI make sense of what's going on right now in a given team. So in this case, we're going to keep it simple, and we're going to make it receive alpha, and we're going to make global alpha increment 1 point, 1 data point. And that's basically it. So for each second that the player is inside the boundary of any of these items, it's going to add 1 data point to the alpha channel. And this data point is supposed to represent red team's chances of victory. So the more points, the more data points red team has, the more likely it is that red team is forecasted to win. So now we're going to make the AI make this assumption based on that. But however, given that there's different weapons and vehicles and different tiers assigned to them, more realistically, you want to go ahead and add more points depending on what they're using. So if a mongoose adds 1 point per second while you're using it, then the warthog would add 2 points and the scorpion would add 3 points because it represents a higher chance of victory. The longer time you spend inside a vehicle, the more it's implied or assumed that you're making better progress than the enemy team. But in this case, just to keep it simple, I'm gonna go ahead and make it add 1 point. If you wanted to add additional points, then you will need to add additional messages in different channels. So basically, um, the AI is always going to add 1 point when it receives, the alpha message. But if you want to add 2 points or 3 points, you would need to add a corresponding channel to it. So channel Bravo would add 1 point to the alpha to the alpha data points, and then Bravo Charlie would add. Oh, I'm sorry, channel Bravo would add 2 points. Channel Charlie would, add 3 points. But that's for more if you want the AI to create a more precise forecast. So it's up to you. But I'm gonna go ahead and leave it simple for now because that's kind of that can be a very tricky mess sometimes. So let's go ahead and leave it like this. So we have the alpha channel here. It's adding 1 point for each time a player is inside these boundaries, right? Okay, cool. So what happens if with this other team? So these, let's see here. So these objects all belong to the attacker. And basically what we're gonna go ahead and do, we're gonna add a script so it can add its own data point every time a enemy team uses, interacts with any of these objects. So let's go ahead and add a script for that. So we're gonna go ahead and use a boundary check continuous like that. We're gonna leave the player objects alone. We're gonna make it detect 1 second, although you can add more time if you like, but again, it depends on the situation. So in this case, we're gonna go ahead and send a message to the Bravo channel, and it's gonna be and we're gonna go ahead and add a script for this to add 1 point per second, 1 point every time he receives a Bravo message. So Bravo, and then we're gonna go ahead and use the Bravo channel, the global Bravo channel, and we're gonna do exactly the same thing, add 1 point to Bravo. So global Bravo is supposed to represent blue team. If blue team is interacting with these objects, it's gonna earn 1 point per second every time it's inside any of these boundaries. And then the same goes for red team when they are, interacting with their own objects. Okay, cool. So now we have like the basic building blocks for a forecast. We scripted a script brain that can essentially, track player data this way and, add these points for record keeping purposes behind the scenes. So what can it do now that it's gathered this data and it has determined that one team has a higher chance of victory than the other? Well, that's up to you to decide what you want to do with this data. In this case, what I can go ahead and do is help the forecasted losing team defeat the winning team by killing a player in the winning team. So basically, this is where the execution AI comes from. If you have enough scripts available, you can do the same thing with the evaluator AI script brain. You don't have to create a separate object, but if you want to do more complicated scripting, chances are you're going to have to create a second object dedicated to taking actions based on the forecast that this thing has come up with. So let's go ahead and add a script to this. So now here is where things get pretty interesting, because number check allows you to compare different variables and different numbers together, and we can actually use this to help out with our forecast. Basically, we can go ahead and create a condition where if global alpha is greater than global bravo, which means red team has a higher chance of winning than blue team, then what we can go ahead and do is kill red team, basically. So we're gonna put in our parameters players, and then we're gonna put team include defenders. So red team is going to be killed every time red team is forecasted to win. Now we're gonna create another script that essentially does this. Hold on. Number check. Now if alpha is less than global bravo, then we're gonna go ahead and make the execution object kill all players in blue team. Okay, great. So we created something pretty basic. However, we're gonna have to do more complicated scripting later on in this video. But for now, let's go ahead and keep it simple. So now we have all of our scripts set up. The scripting is turned on. Everything's so far so good. Now, for the sake of debugging, we want to go ahead and create a script that pretty much resets everything. And this is something that I'm gonna do for the purpose of this tutorial. So number change, global alpha set 0, number change, global bravo set 0, and it just puts everything back together. All right, cool. Now this is where it's gonna go down. Now remember, if I'm in red team and I enter these boundaries that belong to red team, I'm going to be earning data points. Now chances are, based on how this scripting is done, I'm most likely gonna be killed instantly based on the execution of these scripts, but we'll go ahead and get to that in a second. Now, since it's very important that you assign a given team to each object you want to track the team's performance of, because if this was team neutral, basically any player can actually contribute data points for the wrong team, and that's not something we want to do. You want to explicitly mention that this boundary belongs to a given team, and only the player of a given team can trigger the script to detect whether a player is in a given boundary. All right, cool. So let's go ahead and get started. I'm most likely gonna get killed within 1 second of this, so let's go ahead and take a look real quick. All right, so just like that. Okay, so the reason why I died twice is because dead bodies can also contribute data points. I'm actually adding data points right now with this dead body. And basically what you want to go ahead and do is create an object in the form of a fire that can clean up dead bodies. So let's go ahead and do that, because this is adding data points, and this is creating an outlier that cannot be tolerated in our model, because it's going to cause our model to make some incorrect assumptions. So what we're going to go ahead and do is put timer check, and we're going to go ahead and make this thing move constantly towards any dead players' bodies it can find, and it's just going to be constantly doing that. Did explode. select nearest one. All right, so if the body is still present, it's still adding data points to that because unfortunately the boundary system detects dead players too. And basically, we need to clean these bodies up. So this is our way of cleaning our bodies up without this fire getting in the way. So the fire is going to go ahead and look for dead bodies. It's going to look for the closest dead body, and then it's going to return back to its position, because simply by touching it should be enough to disintegrate the dead body. So since we want this fire to be out of the way for gameplay purposes, we want it to immediately return back to its position as soon as it touches the body, within 1 second. And then we want to turn off condition interrupts, so this thing can actually, you know, run its course, because if we leave it on, this action is going to be triggered constantly. It's going to interrupt the object, and that's not what we want to do. So let's go ahead and do this. Okay, so the body already disappeared. It was already cleaned up by the map, but next time it's going to be, we should be able to go ahead and take care of that. So let's go ahead and continue then. So as you can see, red team was forecasted to win by several points because of the dead body. It's going to be cleaned up by the fire. Now, since I don't want to be killed over and over again, what I'm going to go ahead and do is modify the script to add 10 points of 10% of given player's health damage instead. And that way, it shouldn't be an issue. Let's go ahead and reset this thing real quick. And we're going to go ahead and bring everything back to 0. Whoop. Wait a minute. Dead. Oh, my bad. Alright, cool. So we're going to go ahead and reset everything. And we're going to start over again. So let's go ahead and manipulate the forecast once again. Okay, so as you can see, red team is being forecasted to win again, so it's hurting red team players. Now, as I previously mentioned, the boundaries belong to a given team. So if I were to do this on this boundary, nothing would happen, because it's not detecting whether a red team player is inside the boundary. It's detecting a blue team player inside the boundary itself. So let's go ahead and switch to blue team. Let me add a spawn point here real quick. And let's go ahead and switch teams. Alright, let's go ahead and go back to this boundary. And this boundary is not being... Hold on. Attacker. Is it set Bravo? Okay. What is going on here? Okay, there we go. Alright, so now Bravo is being forecasted to win. There we go. Okay, so this is where things get pretty interesting, because the mob is not always going to instantly kill you. Oh, whoops. It's not going to instantly kill you, like, not going to instantly attack you unless it determines that you are on the winning team. So let's go ahead and go back here. See, I'm not taking any points right now because Team Bravo is still being forecasted to win, but as I add more data points, I'm gonna start taking damage. Just like that. 3, 4, 5, 6, 7, 8, 9. Okay, so whoops, 10. Alright, so as you can see, red team is ahead by 9 data points per the forecast. So now we're gonna switch to blue team, and oh, sorry about that. The fire is just disintegrating the bodies. Okay, so now we're gonna go ahead and switch to blue team, and as you can see, I'm not going to be immediately hurt, simply because blue team is trying to catch up in the forecast. So red team is going to be attacked for a while until the AI determines that blue team is ahead, like it did just now. So it takes some time for the model to adjust, and you need to be very sensitive about how many points an object, how many data points a given object provides, because you need to be more realistic about this. Generally speaking, a Scorpion should help the team catch up in terms of data points faster than on a Mongoose, because the Scorpion is more deadly, therefore it should be able to add more data points. So this is where things get a little bit more complicated. I'm not gonna wait 10 seconds inside a Scorpion when it's pretty obvious that Scorpion is going to overwhelmingly improve your chances of victory. So let's go ahead and modify our scripting a little bit and show you how much more complicated this can get. So in this case, I'm gonna go ahead and take a Warthog. and we're gonna go ahead and send it a message to the Bravo channel. So Bravo's going to change. Bravo's definitely going to change priorities, okay? And then we're gonna make the Scorpion send a message to the Charlie channel. We want to make our model more accurate and more realistic about its forecasting, so we need to go ahead and modify these messages and how this AI evaluates the messages. Now, like I previously mentioned, in order to make a more accurate model, you need to add more scripts, so things are going to get more complicated. And that means you're most likely to need to create an executioner object in order to be able to carry out the accurate evaluation of the evaluator objects. So alpha, we're gonna go ahead, message receive alpha condition, we're gonna leave it alone for this object, and we're gonna go ahead and modify this a little bit. So once we receive Bravo message, instead of adding a data point to Bravo, it's going to add 2 data points to message alpha, and then we're gonna add another script in the Charlie channel, which is going to increment 3 data points to the alpha channel, because Scorpions have a higher chance of victory than a mongoose. So let's go ahead and do that. And then same thing for rocket launcher. It's a tier 3 weapon, so it's a weapon powerful enough to destroy vehicles. So we're gonna go ahead and send it a message to the Charlie channel as well. For the script brain, this is tracking the player's location instead of what it's interacting with. So this is more situational. For example, you can make it add 1 data point if it's in its own base. The player is in its own base. But you can make it add 2 data points if it's in the middle of the map because it's closer to the enemy team's base, and then make it add 3 data points to if the player is in the enemy team's base, because that means they're very close to reaching their objective, such as capture the flag, for example. So basically, but we're gonna go ahead and leave this alone since this is a more situational object. So we created those scripts, and now we're gonna go ahead and modify those scripts. So we're gonna add 3 more scripts in for blue team, and basically we're gonna go ahead and respond to message received delta. So in this case, we're gonna add 1 data point for Bravo, and then we're gonna go ahead and go to the echo channel and make it add 2 data points for Bravo. And then we're gonna go ahead and create a Foxtrot channel, and we're gonna go ahead and make it increment 3 data points for Bravo as well to represent the type of weapons that we're using. Now we gotta go ahead and modify these scripts as well. This is where scripting can get tricky, because you might forget that you have these objects here that need to be sending messages in different channels, and this one's gonna be Delta. This one we're gonna make it Foxtrot instead of Echo because it's a tier 3 weapon, and then we're gonna make it Delta for 1 data point. Okay, cool. So let's go ahead and reset everything back to 0 data points for both teams, so it doesn't bias its prediction. And we're gonna go ahead and make it add 1 data point per second because it's on the mongoose. 5, 6, 7, 8, 9. Okay, so now blue team is ahead by 9 data points, right? So let's go ahead and see how long it takes for red team to catch up now, since they essentially have a very powerful vehicle. Now remember, this is supposed to add 3 data points per second on red team. So let's go ahead and see. So it took 3 seconds to catch up to blue team, and that's because more realistically, Scorpions have a higher chance of victory than mongoose. So the AI is going to be taking that in mind, making these evaluations. Now, as you can see, we have 6 scripts because we're trying to create a more accurate model. We need 2 more scripts to max out the script limit for a given object. So this only has 2 scripts available in order to be able to do so. Now, if we want to go ahead and do something more fancy regarding the forecast, we're gonna go ahead and fill out these 2 final scripts this way. So we're gonna go ahead and make it do a comparison. So if global alpha is greater than global bravo, that means red team is ahead. We're gonna go ahead and create a switch in the alpha channel to turn it on, and then for our final script we're gonna do the opposite. So basically we're gonna go ahead and make another comparison: global alpha less than global bravo, And basically we're gonna go ahead. So basically we're gonna go ahead and create a less than global Bravo, and we're gonna go ahead and turn this channel off. Turn this power alpha channel off to represent that blue team is ahead instead of red team. So now we're gonna go ahead and do something a little bit more complicated. So let's go ahead and do something here. So instead of immediately responding to a team's forecasted chances of victory, because we don't want red team to be, killed or at least harassed every time, something comes up. So in this case, we're gonna go ahead and, modify our scripting a little bit. So let's go ahead and go to our executioner object and change its condition. In this case, we're gonna give it a timer, and every 15 seconds, it's gonna take a given action. And this action is going to be sending a message to itself. Now we have all of these channels that we already used up, so we're gonna have to go all the way to the bottom and go to the golf channel, which is where things get pretty, like if you're already creating a script and you're already using the golf channel, regardless of which variable or which power or message you want to use, like you already know you're creating a lot of scripting. So message send golf, and essentially it sends a message to itself every 15 seconds. And why it needs to send a message to itself is because it needs to determine it needs to be told who's winning, right, who's forecasted to win right now. So basically it's gonna go ahead and create a twofold condition where it detects once it receives the message every 15 seconds, and then it's going to check who's forecasted to win right now. So we're gonna go ahead and create two additional scripts. This would be our first script. It's going to check every 15 seconds whose team is winning. In this case, it's checking if red team is winning, and we're gonna go ahead and turn this up a few notches and make it kill red team. Oh, whoops, red team. All right, so since red team is winning, red team is gonna be killed every 15 seconds. Now for our other script, we're gonna go ahead and do another one. In this case, we're gonna go ahead and do the opposite. So it's gonna send a golf message to itself, and then it's gonna check if blue team is forecasted to win right now. In this case, we're just gonna go ahead and damage ratio 100, and we're gonna make it attack blue team, pretty much. Team include blue team, and it's gonna add 100 points of damage to that. So this is pretty much checking every 15 seconds who's winning and what it's going to do about it. Now you can do whichever, you can make it like take whatever decision you want it to, via scripting, it's up to you. But for the purpose of this tutorial, we're just gonna make it kill red team kill the winning forecasted team every second. Now, keep in mind that just because the AI is predicting which team will win doesn't necessarily mean that the team is actually winning or is actually going to win. It just assumes that one team is going to win over the other based on the data it gathered by tracking all of these objects together. And that's pretty much how you create an AI that can actually think before it acts instead of acting on the moment once it detects something. So let's go ahead and reset everything and bring everything back together. Now, this is going to be a more subtle process because you have this executioner object that is essentially evaluating whose team is winning every 15 seconds. So it's going to take a decision based on that. Now, since I reset everything back to 0, nobody's winning right now. So in this case, let's go ahead and make it create a forecast here. All right, so I'm actually earning a lot of data points compared to Among Us because we scripted our Scorpion to determine our chances of victory. And now the executioner object has essentially determined that I'm winning right now by a lot because of that. So our little flame here is cleaning up dead bodies. It's actually a workaround I use in order to try to eliminate dead bodies as much as possible so it doesn't tamper with the model as much. Now, the AI is still forecasting victory on my end. It still thinks that I'm essentially determined to win, and it makes sense this way because the team hasn't touched any weapons or vehicles on there. We haven't touched anything. So that just simply means that, we have the upper hand. Now, let me go ahead and switch over to blue team, and I'm going to help blue team catch up on the forecast real quick. So I'm just going to go ahead and drive this Scorpion, which is the fastest way to pretty much earn data points, and that way change the the forecast of the model this way. So I'm gonna have to wait a little bit longer here because, according to the model, blue team needs to catch up because they spent a long time without using any weapons or vehicles or interacting with anything. So now that blue team's already caught up, we're gonna go ahead and make red team catch up this time. So this time we're gonna go ahead and take the slower route, and we're gonna use the DMR to essentially earn data points. Now this is going to take longer to catch up because the model is forecasting that DMR is not really going to turn the tide of battle as quick as having a Scorpion. So in this case, it's gonna take a while for the model to update its forecast, but you can actually make this forecast add up by essentially. Oh, it already caught up. Whoops. Okay. So I take that back. It looks like it already caught up quicker than expected. But in order to make catch up even faster than that, what we can go ahead and do is combine different data tracking stuff. So if, for example, you have DMR, which earns 1 data point, a rocket launcher that earns 3 data points, and then you're standing on a location that adds data points, then it's going to catch up a lot faster than if you simply had those 3 things individually. And these things actually interact with each other this way in terms of tracking, and it actually makes a lot of sense how they actually catch up to each other because they can, it just implies that if you're using all of these things and you're moving around a lot in different places, then the model's going to think within reason that your team is the winning team, and therefore it needs to help the losing team, do something about it. But that's just one way to do it. Depending on, remember, in this tutorial, we want to emphasize the forecast, the ability to evaluate a given situation. We don't really want to focus too much on what it does with this information, only that it can gather this information for future reference. Also, keep in mind that you do want to take note that the data points that you gather are actually carried over to the next round. So this data that it gathered in the previous rounds is actually recorded and passed on to the other rounds. So it already made a forecast before the round even started, or at least when the round starts, it already made up its mind based on the information provided in the previous round. So it does keep track of player data in real time and actually passes it on to future rounds. It doesn't pass it on to future games, but that's okay because each game is different. But the fact that it can actually pass it on to future rounds is incredibly advanced and impressive. And if you can actually learn how to harness this thing and create a precise model, then you can actually create a very revolutionary program that can not only help you Halo 5 Forge, but can actually help you in the programming world in general. So that will be all for today. I hope you stuck around for this very lengthy tutorial video, and I hope you enjoy. So don't forget to like and subscribe.